If this set is an orthogonal set of non-zero vectors in Rn, then it must be linearly independent, it being S. So I need to show that S is linearly independent. Consider C1U1 plus C2U2 all the way down to CNUN equals 0. Somehow I have to conclude that those constants are all 0. And all I have is that this set is orthogonal and none of the vectors are 0. So compute Ci. I didn't mean that, please. I meant U sub I. I take one of these vectors, U sub I, and I dot it with this. C1U1 plus C2U2 all the way down to C sub n, U sub n. And this is going to be U sub I dotted with the 0 vector. Okay, so what we get is C1 times U sub I dotted with U1 plus U2 times U sub I dotted with U2 all the way down to eventually Ci, where Ui is dotted with U sub I, all the way down to C sub n times Ui dotted with U sub n. And this is 0. Now, we know that this is 0. So you have Ci times 0. Why? Because in a orthogonal set, you dot any two different vectors, you get 0. This is 0. This is 0. So we have that 0. I didn't mean to say that this is 0. And we have this is 0. And this here is just the length of U sub I. So we have Ci times 0, C1 times 0, plus C2 times 0, all the way down to C sub I times the length of Ui. Since it's not 0, since this dot product is not 0, that means that since U sub I, since U sub I is not the 0 vector, its length won't be 0. Okay? This is not 0. All the way down to plus C sub n times 0 is equal to 0. Well, this tells us that Ci times the length of U sub I squared, which is not 0, is equal to 0. But that implies Ci equals to 0, but this is for all I equal 1, 2, up to n. So C1 equals C2 all the way down to C sub n equals 0. Hence, S is a linearly independent set of vectors. And that completes this video. All I did, or completes this proof, all I did was use the definition. If you like videos like this, please subscribe to my channel. All we do is proofs on this channel. Mathematical proofs from all areas of mathematics. Please subscribe. See you guys in the next video. Watch and learn.